This video is for class 10 students. The chapter is Introduction to Trigonometry. In this video, I am solving exercise 8.4. Okay, so this is the exercise 8.4 which you need to know the concepts of. Now let's see. Before we get into the exercise, let's revise a review of the ratios and the identities. Let's have a quick revision of the ratios and identities. Now the ratio, which is the ratios? So this is the triangle. Now this is a right angle triangle. Here this angle is 90 degrees. This is angle theta. If this is the angle here, the side opposite this is the opposite side. So AB is the opposite side and the side which is on the base is the adjacent side, base. And this longest side is the hypotenuse. Okay. So I have named it so that you get a clear idea of what each side is. Opposite, adjacent and hypotenuse. Now, based on this angle, we try to write the ratios. Let's take the first ratio. So there are three ratios which we call as the fundamental ratios or the basic ratios. The first basic ratio is the sine angle, sine of theta. That is just written as sin theta. Okay, its full form is sine. Sine is given by the ratio opposite upon hypotenuse. Opposite means the side is opposite, so that is AB, and hypotenuse is AC. So opposite upon hypotenuse is the sine of the angle theta. Next is cosine. Cosine theta or cos theta. It is adjacent upon hypotenuse. Adjacent is BC, hypotenuse is AC. Third one, tangent theta or tan theta, opposite by adjacent. Opposite is AB, adjacent is BC, sorry. Now, we take the reciprocal of this, that is the next ratio, that is the reciprocal of the basic ratios. Now, reciprocal of this ratio is nothing but the cosec, cosecant, cosec or cosecant. We usually write it as cosec theta. This is cosecant. So it is hypotenuse upon opposite. Hypotenuse upon opposite. Hypotenuse is AC. Opposite is AB. AC upon AB. Now you see this. AB upon AC. This is AC upon AB. So that means cosec is the reciprocal of sine. Okay. Next, we take the reciprocal of cos. So that is secant. Secant theta or sec theta, it is hypotenuse upon adjacent, that is AC upon BC. AC upon BC. The next ratio is cotangent or cot theta, adjacent by hypotenuse. Adjacent by hypotenuse, you can see it is BC upon AC. So these three are the base reciprocals of this fundamental ratios. Okay. So once you remember this, you should know that these are nothing but the reciprocals. Yeah. Now, how to remember these six ratios? What do we do is I have framed a thing like this. See, if you go from this to the top to bottom, top to bottom, top to bottom, this sine, cos, tan. And this from bottom to top, if you go, this cosec, sec, cot. Okay. O, A, O, H, H, A. So you can remember it as Om Anjaneya Om Hara Hara Anjaneya. This way. Okay. If you remember this, you should remember this is from top to bottom, it is the fundamental ratios. And from bottom to top, it is the reciprocal ratios or cosec, sec, and cot. Now let's go further. More forms of the above ratios. The ratios which you have studied, we'll see what are the other different forms. Now, cosec. Cosec, as I told you, it is a reciprocal of sine. So cosec can be written as 1 upon sine. Sine can be written as 1 upon cosec. It is a reciprocal. So cosec is 1 upon sine, or you can take the sine this side and cosec down. It is sine is equal to 1 upon cosec. Because in this ratio exercise which we are going to solve 8.4, here we will need different forms of it. That's why I have written specifically mentioning the types. Next, Secant theta or sec theta is 1 by cos, or cos is equal to 1 by sec. Cot theta is 1 by tan, or tan theta is equal to 1 by cot. Okay, so it could be written this way, or it can be written depending upon our need and what you have to prove. Now, sine theta upon cos theta. Let us take this ratio. Sine theta upon cos theta. What is sine? Opposite upon hypotenuse upon adjacent upon hypotenuse. That is opposite upon hypotenuse into hypotenuse upon adjacent. Because the division, you take the reciprocal and multiply it. So hypotenuse gets cancelled. And what you are left with? Opposite upon adjacent. Opposite upon adjacent, what it is? It is nothing but the tan of the angle. So that means you have one more relation. Tan theta is equal to sine theta upon cos theta. Okay? Because we have learned only in this form, tan theta is opposite upon adjacent, but tan theta can also be written as sine theta upon cos theta. So tan theta is sine theta upon cos theta. But what we know, cot is nothing but reciprocal of tan. So when you write cot theta is cos upon sine. Yeah. So these are the different forms where you have to remember that when you want to prove some identities, we need all these values. That's why keep a note of all this. Now sec into cosec, sine. Sine into cosec is 1. Sine theta into cosec theta is 1. How it is? Sine. And what is cosec? Cosec is 1 by sine. So this sine cancels and it is just equal to 1. So that's why sine into cosec is 1. Now, cos into sec. Again, cos into 1 by cos because sec is 1 by cos. This also cancels and it is just equal to 1. Okay. Tan into cot. That is tan into 1 by tan. Tan cancels. It is also equal to 1. So tan, so you see sec into cosec is 1. Cos into sec is 1. Tan into cot is 1. Yeah. So you can remember this also. That means if you get this somewhere in your multiplying, when you're multiplying the ratio, and if you're getting this, you just write it is equal to 1. Why? This is an explanation. Okay. Now next go to proof of identities. Now we are learning a few identities here. In this, the first identity which we will be taking is, see, before we get into the identities, we learn all these ratios. Okay. Sine is AB upon AC. So these are the ratios which we have learned, all the 6 ratios. This is the figure which we are having. Okay. Clear? I think this is clear now. Now, see the first, sine square theta plus cos square theta. Sine square means AB upon AC whole square. Plus cos square means BC upon AC whole square. So like this, when you write it is that when a square of the numerator and also of the denominator it is, that means it is AB square upon AC square plus BC square upon AC square. Denominator both are AC square. You can take it as an LCM. So it becomes AC square, AB square plus BC square. Now this is a Pythagoras theorem. You see, AB square plus BC square is just but equal to AC square by Pythagoras theorem. That means you can write the numerator as AC square upon AC square. AC square will get cancelled and it is just equal to 1. So you are getting sine square theta plus cos square theta is 1. Next, 1 plus tan square theta. 1 plus tan is what? AB upon BC. AB upon BC whole square, which is equal to 1 plus AB square upon BC square. Take LCM here. So you'll get BC square plus AB square upon BC square. AB square plus BC square we are just written as AC square. So let us write it as AC square. AC square upon BC square. That is AC upon BC. AC upon BC is nothing but sec. So it is sec square theta. So 1 plus tan square theta is sec square theta. Once you know these ratios, we come to know how this has been derived. Next, proof of the one more ratio identity, same this is the figure. So these are the ratios. 1 plus cot square theta is equal to 1 plus cot. What is cot? It is BC upon AB whole square, which is equal to BC square upon AB square, which is also equal to AB square plus BC square upon AB square. AB square plus BC square is AC square. So AC square upon AB. AC upon AB is nothing but cosec. So it is cosec square theta. So 1 plus cot square theta is cosec square theta. So we have learned three identities. These are the three identities which we are learning. Sin square theta plus cos square theta is 1. 1 plus tan square theta is sec square theta, and 1 plus cot square theta is cosec square theta. These are the three identities, basic identities here. Now, these identities can also be written in a different form. So what are the other forms? Other forms of the basic identity. The basic identity which you have learned first is sin square theta plus cos square theta is 1. Now, when I take cos square this side, what will happen? Sin square is equal to 1 minus cos square. So I can write this in this form also. Or I can take cos square, sin square this side, and it becomes cos square is equal to 1 minus sin square. So you can write this identity in this way also. It's also in this way. So you can write sin square plus cos square as 1, or sin square is equal to 1 minus cos square, or cos square is equal to 1 minus sin square. Now let us take the second identity. 1 plus tan square is equal to sec square. Take this 1 this side. So it becomes tan square is equal to sec square minus 1. Or let us take tan this side. It becomes tan square, sec square theta minus tan square theta is 1. Or when you take this side, here only 1 is left. So it is sec square theta plus tan square theta is 1. Now the third identity. The third identity is 1 plus cosec square, cot square theta is equal to cosec square theta. Now if you see here, when you take this one, take 1 this side becomes cot square theta is equal to cosec square theta minus 1. Or cosec square theta minus cot square theta is 1. Now this is, if you see here this identity, sec square theta minus tan square theta is 1. So you can write it as a square minus b square. And as per our basic identity, we know that a square minus b square is a plus b, a minus b. So this could also be written as sec theta plus tan theta. In another bracket, sec theta minus tan theta is 1. So this identity could also be written in this one. Or this one also can be written in a similar way. Cosec plus cot theta into cosec theta minus cot theta is 1. Yeah. Now this further we can sin theta is what? Sin square theta is 1 minus cos square theta. So sin theta will be square root of 1 minus cos square theta. Or cos theta could be square root of 1 minus sin square theta. Here also I use the same concept. Tan theta is equal to square root of sec square theta minus 1. Or sec theta is equal to square root of 1 plus tan square theta. Sec square theta it is. So it is sec will be square root of this. Next. Cot could be written as square root of cosec square theta minus 1. Or cosec could be written as root of 1 plus cot square theta. So the three basic, we have learned only the three basic identities, but this basic three identities, you see how many different forms you can write them. So almost 3, 4, 12, and 14 forms I have written there. Three identities been split into this. So these different forms are used while proving the other identities in the exercise. Now, a little bit about complementary angles. Now let us see what is a complement angle. Now, this is a triangle. Now, if you see here, this is the angle theta, and this is a right angle triangle. And when you say triangle, the sum of the angles of a triangle is 180 degrees. So we know that the sum of the angles of a triangle is 180. That means angle A plus angle B plus angle C is equal to 180 degrees. But angle B is given as 90 here. So let's substitute it here. So it comes angle A plus 90 plus angle C is 180. Take 90 this side. It becomes angle A plus angle C is 180 minus 90. Angle A plus angle C is 90. Now, since the sum of the two angles is 90 degrees, we say that angle A and angle C are complement to each other. Okay? If the addition of the two angles, if it is equal to 90 degrees, then the two angles are complement to each other. Now here, when you see here, I have written angle C as theta. So if angle C is theta, therefore angle A, what it will be? Angle A will be 90 minus theta. So this is angle A, which is 90 minus theta, which is a complement of angle C. So let's mention it here, 90 minus theta. So this is the complement angle of angle C, or angle C is the complement of angle A. Now let's write the 6 ratios. So here got this is the main figure. Now we start with the first angle. Taking theta as an angle, we write the 6 ratios. First ratio, sine theta, is opposite upon hypotenuse, that is AB upon AC. Cos theta is BC upon AC, adjacent upon hypotenuse. Tan theta is opposite upon adjacent, that is AB upon BC. Cosec is hypotenuse upon opposite, that is AC upon AB. Sec theta is hypotenuse upon adjacent, that is AC upon BC. Cot theta is adjacent upon opposite, that is BC upon AB. These are the 6 ratios. These are the 6 ratios using the angle theta. Now let us take the complement angle, that is 90 minus theta, and write. Once you take complement angle, now here the opposite and adjacent will change their positions. So where in place of adjacent, it will become opposite, because here this angle, this is the side which is in front of 90 minus theta. So this becomes the opposite. So the figure will be like this now. So here the opposite, and here this will be adjacent. So my angle is, so with respect to 90 minus theta, let us write the 6 ratios again. Sine 90 minus theta. Sine 90 is opposite upon hypotenuse. Opposite is here now BC. So BC upon AC. Cos 90 minus theta. Adjacent, that is AB upon AC. Tan 90 minus theta is opposite upon adjacent, that is BC upon AB. Cosec 90 minus theta is hypotenuse upon opposite, that is AC upon BC. Sec 90 minus theta is AC upon AB. Cot 90 minus theta is AB upon BC. So these are the 6 ratios using the complement angle, that is 90 minus theta. And these are the main angles using theta as the main angle. Okay. Now let us try to find a relation between these two. In what way 90 minus theta and theta are related with each other? For that, we just do something called match the following. So when you try to match the two things, now what we have learned, we have written all those ratios which I have written, make a note of it. So these are the 12 ratios which I have written. Now let us try to match them. Now you see your first one, see here, BC upon AC, and here also you have got BC upon AC. That means these two ratios are same. What it is? Sine 90 minus theta, and what here you have got? Cos theta. So that means your first relation between them is sine 90 minus theta is cos theta. The relation between sine theta and its complement. Next, AB upon AC, AB upon AC. These two are complementary relations. So this is, you can write cos 90 minus theta is sine theta. Take the third one. BC upon AB, BC upon AB, it's here. So that means tan 90 minus theta is cot theta. tan 90 minus theta cot theta. Next, cosec. Cosec 90 minus theta, AC upon BC. You have got AC upon BC here at sec theta. So this is a pairing. Cosec 90 minus theta is sec theta. Next, sec 90 minus theta is cosec theta. This is the pair. So it is sec 90 minus theta is cosec theta. And the last one, cot 90 minus theta is tan theta. This cot 90 minus theta is tan theta. So this is the relation between the angle and its complement. You need to remember this. Okay. So it's easy. Sine is cos, cos is sine, tan is cot, cosec, sec, sec, cosec, cot, tan. Okay. We need to remember this because whenever you're coming across complementary angles, we need this relation. Now let's further proceed. Now let's take the first question from exercise 8.4. Express the trigonometric ratios sin A, sec A, and tan A in terms of cot. That means that represent all these in terms of cot only. So let us take the first one, sine. Sine A. What is sine? Sine is equal to 1 upon cosec. Now, cosec is square root of 1 minus root of 1 plus cot square. So let us replace this in this place. That becomes sine is equal to 1 upon root of 1 plus cot square A. So this is expressing sine in terms of cot. Now let us take sec. Sec is what? Sec is equal to square root of 1 plus tan square theta. Now tan theta is equal to 1 by cot theta. So if you write tan square theta, it will be 1 by cot square theta. That means sec square theta is square root of 1 plus 1 upon cot square theta. And the last one, tan. Tan is nothing but the reciprocal of cot. So tan theta is equal to 1 by cot theta. So that's how we have expressed sine, sec, and tan in terms of cot. Next question, second question number. Write all other trigonometric ratios of angle A in terms of sec A. That means all the 6 ratios to be written in terms of secant of an angle. First one, sine. Sine is square root of 1 minus cos square theta. Cos theta is 1 by sec theta. So it will be sine, and cos square will be 1 upon sec square. So sine is equal to square root of 1 minus 1 upon sec square theta. Next, cos. Cos is 1 by sec. Then tan. Tan is sec square theta minus 1. Cos theta is equal to root of 1 minus sin square theta. Cosec is equal to 1 upon root of 1 minus 1 by sec square theta. Sec theta is equal, cosec theta is equal to square root of, let's take LCM here, it becomes sec square theta minus 1 upon sec theta, sec square theta. Everything inside the root sign. So cosec is, and this one is a numerator upon numerator. So this numerator thing will go to the numerator. So this one, it is inside the root sign and it is having a sec square theta. So when it comes outside the radical sign, it becomes only sec theta. So sec theta is in the numerator and square root of. So it will be cosec is equal to sec theta upon root of sec square theta minus 1. Cot theta is 1 by tan theta. What is tan? Tan is equal to root of sec square theta minus 1. So cot is equal to 1 upon root of sec square theta minus 1. So here we have written all the 6 ratios in terms of sec of the angle. Now question number 3. Here see sine square. So here we need to use the concept of complementary angles. Take the first one. So we have written down all the relation between the angle and its complementary angles. So once you are knowing, let's remember this. And now let us take the first question. Sine square 63 degrees plus sine square 27 degrees upon cos square 17 degrees plus cos square 73 degrees. Now, what do you write? Sine square 63 plus sine square 27 can be written as 90 minus 63. 90 minus 63 is 27. So I am expressing 27 as a difference of 90 and other number. 90 minus 63 is 27. So it has become sine 90 minus theta. Sine 90 minus theta is nothing but cos theta. Here your theta is 63. Similarly, here I am going to express cos 17 can be written as 90 minus 73. So 90 minus 73 plus cos square 73. So here cos 90 minus theta is sine theta. And here your theta is 73. So here what will happen? It becomes sine square 63 plus cos square 63 upon sine square 73 plus cos square 73. This is sine square theta plus cos square theta. So sine square theta plus cos square theta is 1. So numerator is 1. Here also same 1. So it is 1 upon 1. It is 1. So the answer to the first bit is 1. Take the second bit. Now here sine 25 degrees cos 65 plus cos 25 sine 65. This could be written again. I'm changing 1 from this side and changing 1 from here. So it becomes sine 25 cos 90 minus 25 is 65. And here cos 25 sine 90 minus 25 is 65. So 90 minus theta is sine theta. So it becomes sine 25 sine 25 plus cos 25 plus cos 25. Sine into sine is sine square. So it becomes sine square 25 plus cos square 25. Sine square plus cos square, just you have learned here, it's 1. So that means this should be 1. So the second bit answer is also 1. Fourth question. Choose the correct option. Justify your choice. Now here the first is 9 sec square a minus 9 tan square a is equal to how much? 4 options are given. 1, 9, 8 and 0, which is the correct answer you have to choose. Now you see here, both are having 9 in front of it. So take out common 9. Sec square minus tan square. 9 is outside the bracket. So sec square minus tan square is 1. So 9 into 1 is 9. So your answer is option B. So because sec square minus tan square is 1. So your option B is your answer. Third bit. Sec A plus tan A into 1 minus tan A. The 4 options given are sec A, sin A, cosec A, cos A. Let's see how to solve it. Sec is 1 by cos, tan is sin by cos into 1 minus sin. Here in the first bracket, both have the same denominator, cos, cos. So you can take an LCM here. It becomes 1 plus sin upon cos into 1 minus sin. So numerator multiplies 1 plus sin, 1 minus sin. That means A plus B, A minus B. Yes? It should be A square minus B square. So if you write it in that form, it becomes sin 1 plus sin 1 minus sin upon cos. So A square minus B square is 1 minus sin square. 1 minus sin square is nothing but cos square. Cos square upon cos. So here there are 2 cos and there is a bottom denominator has only 1 cos. 1 cancels and your answer will be cos A. Cos A, that is this option D. So your answer is option D. And let's go to the second bit here. 1 plus tan theta plus sec theta, first bracket. Second bracket has got 1 plus cot minus cosec. So the 4 options given is 0, 1, 2 and minus 1. Now let's see what works out. First let us multiply these two. 1 into the full second bracket plus tan into the second bracket plus sec into the second bracket. So 1 into tan, so if you multiply all this, it will become 1 into 1, 1. 1 into cot is cot plus minus 1 into cosec. Tan into 1 is tan, so it will be like this. 1 plus cot minus cosec. Tan into 1 is tan into cot minus tan into cosec, plus sec into 1 is sec, plus sec into cot minus sec into cosec. Now let's see here. 1 plus cot minus cosec. Tan into cot. Cot, you know, it is 1 upon tan. So replace cot with 1 by tan. Minus tan is sine upon cos and cosec is 1 by sine. So sine upon cos into 1 by sine. Plus sec. Plus 1 by cos into cos upon sine minus sine sec into cosec. So here if you see this cancels. Tan cancels. Sine cancels. Cos also cancels. What all is left? Let us write it down. 1 plus cot minus cosec plus tan plus 1 minus 1 upon cos means sec it is, plus sec. Again here 1 upon sine is cosec minus sec cosec. Now if you see here, minus cosec plus cosec. So this should get, these two should get cancelled. Plus sec minus sec. These two should also get cancelled. So write down what is remaining. 1 plus cot plus tan plus 1 minus sec cosec. Here we have got sec and cosec, and here we have got cot and tan. So let us express this in terms of sine and cos. Let be cot can be written as cos upon sine, and tan can be written as sine upon cos plus 1 minus sec cosec. Let us take LCM of these two terms only. It becomes cos into cos, cos square, plus sine into sine, sine square upon sine cos, plus 1 into this. Sine square plus cos square is 1. So you write it as 1 upon sine cos plus 1 minus sec cosec. Here 1 upon sine is cosec and 1 upon cos is sec. So it will become sec cosec plus 1 minus. So this is plus sec cosec and this is minus sec cosec. These two should also get cancelled. So 1 plus 1. What is left? They are left with 1 plus 1 which is equal to 2. That means your second the answer, option C is your answer. So answer is option C. Now the fourth bit. 1 plus tan square A upon 1 plus cot square A. Now to see which one is the correct answer. Now 1 plus tan square A is sec square A and 1 plus cot square A is cosec square A. So let us replace these with that. So it will be sec square A upon cosec square A. That is 1 upon cosec square means 1 upon cos square into is in the denominator. So take the reciprocal, it becomes sine square upon 1. So that is sine square upon cos square. Sine square upon cos square is tan square. So your answer is option D. Now let's start to question number 5. Question 5. Prove the following identities where the angle involved are acute angles for which the expressions are defined. Okay, the angles are acute angles. Let's take the first bit. Cosec theta minus cot theta whole square is equal to this. This is a square, it should be by mistake. This. So cosec is 1 by sine, cot is cos upon sine raised to 2. Denominator being same, write it as it is. So 1 minus cos upon sine whole square. So 1 minus cos whole square and it is 1. So it should be 1 minus cos whole square upon sine square theta. This bracket is 2 times, so write it 2 times. And sine square is equal to 1 minus cos square. So it is 1 minus cos theta, 1 minus cos theta upon 1 minus cos square theta. 1 minus cos square theta can be written as a square minus b square. A square minus b square is a plus b, a minus b. So a square minus b square is a plus b, a minus b. So let's use that for the denominator. So the numerator is 1 minus cos theta, 1 minus cos theta, 1 minus cos theta, 1 plus cos theta. 1 minus cancels. So your answer is 1 minus cos theta upon 1 plus cos theta. So here this is what we wanted it. So it is 2. Now let's take the second question. Cos upon 1 plus sine plus 1 plus sine upon cos. So here we take the LCM of the sine. So cos into cos plus 1 plus sine into 1 plus sine upon denominator 1 plus sine into cos. Cos into cos is cos square and 1 plus sine into 1 plus sine is 1 plus sine whole square. So it will be cos a whole square plus 1 plus sine a whole square upon this. Now for the second bracket we use the formula a plus b whole square is equal to a square plus b square plus 2ab. A is 1, b is sine. So let us put that here. So it is cos square a plus a square means 1 square, b square is sine square plus 2 into 1 into sine a is 2 sine a upon. Now sine square a, cos square a. Sine square a plus cos square a is 1. So let us bring these two terms together. Sine square a plus cos square a plus 1 plus 2 sine a. So sine square plus cos square is 1. So let's substitute this value here. It becomes 1 plus 1 plus 2 sine a. 1 plus 1 is 2. 2 plus 2 sine a upon 1 plus sine a into cos. Let us take out 2 common here. It becomes 2 bracket 1 plus sine upon 1 plus sine upon cos. This cancels. Therefore, you are left with only 2 upon cos. 1 upon cos is sec. So you can write this as 2 sec a. This is how we are proving this. So this is what we wanted it. And we have proved this. Now let us take the third question. Now, tan. Now here, this is a little tough question. And this particular question, make sure that you will understand this and you learn this by almost every year we are expecting this question, and it has been coming in papers, in the CBSE board papers. So please make sure that you are understanding this particular question particularly. Now, first what I am doing is tan theta I am keeping as it is, cot I am changing it as 1 by tan and keeping this as it is. So I'll take LCM here. It becomes tan theta upon tan theta minus 1 upon tan theta plus cot upon 1 minus tan. This denominator goes to the numerator. It becomes tan square theta upon tan theta minus 1 plus cot theta upon 1 minus tan theta. Now here there's a slight difference here, you see. Tan theta minus 1 and this is 1 minus tan theta. So what we do, you see here, these two are slightly, there's a difference. So what you should do, suppose here, minus if I take minus sign and 1 minus tan if I take. That means if I take the minus of this, so and open the bracket, become minus 1 minus minus plus tan theta. So that means what when I take a minus sign, it will become minus 1 plus tan theta, or tan, write the positive term first and minus afterwards. So it is tan theta minus 1. So tan theta minus 1 or 1 minus tan theta can be written as taking a minus sign here, it will become tan theta minus 1. So we are using tan square theta upon tan theta minus 1. I change the sign as minus cot theta upon tan theta minus 1. I think you have understood why it is. By changing the position of these two terms, the sign in the middle will change. This is the explanation for that. Now here both have the same denominator, so it is tan square theta upon this minus cot I am writing as 1 by tan into tan theta minus 1. So LCM is tan theta minus 1. LCM is tan theta minus 1. And so here numerator. So what I do, I am taking LCM of the numerator. So tan theta into tan theta minus 1 into 1 upon tan theta minus 1. This is tan raised to 3 theta, and 1 also can be written as 1 raised to 3 theta, and this tan theta will come to the denominator. It is tan theta minus 1. Here I am going to use a raised to 3 minus b raised to 3 identity. A raised to 3 minus b raised to 3 is a minus b, a square plus ab plus b square. So let us write that. It is tan is a and 1 is b. So a minus b. So tan minus 1, tan square plus 1 into AB, that is 1 into tan plus 1 square. So upon this 1 square, this it is square resist. So tan into tan minus 1. So again write it. This tan cancels. So what do you left? Tan square plus 1 plus tan upon only tan is it. Let us split this below all the three. So you'll get tan square plus 1 upon tan upon tan. We'll break it down. It will become tan square upon tan, 1 upon tan plus tan upon tan. So this 1 tan cancels here. This is cot and this is 1. So what you are left with? Tan plus cot plus 1. Okay. So here this is what we get. Tan plus cot plus 1. Now we want to answer in this form. So what we do, take this. Tan can be written as sine upon cos and cot can be written as cos upon sine plus 1. Take LCM of these two terms. It becomes sine square plus cos square upon sine cos. Sine square plus cos square is 1. So you get 1 upon sine cos plus 1. 1 upon sine is cosec. 1 upon cos is sec. So you'll get, you break it down, 1 upon sine into 1 upon cos plus 1. So you'll get cosec plus sine, sec plus 1. So cosec plus sec plus 1. This is the thing which we wanted to prove. So we got what is to be proved. Okay. So this is an important question. It's from your NCERT textbook. At times, the same question, the answer has slightly changed and it is to end here. So sometimes they end it here. This has, they say that proof this is equal to tan plus cot plus 1. So the same proof, you stop at this stage, you get this answer. If you go further, you get this answer which is here. Okay. So that is the thing. So actually, in some question papers, it has ended here and they expected you to prove this much only. This much was not expected. But here is this other thing. So both the things you must be thorough with. Now let's take the next question. Fourth one. Here we will first start with the left side. Because that if you do this way, this becomes easier and faster. So 1 plus sec upon sec. What is sec? 1 by cos. 1 upon cos upon sec. Take LCM. So sec cos minus 1 upon 1 upon cos. Denominator division it is. So it will be cos plus 1 upon cos into 1 upon cos. This cancels. So you are left with only 1 plus cos. Now take the right side. Sine square upon 1 minus cos. What is sine square? Sine square, if you remember, it is 1 minus cos square. Sine square is 1 minus cos square. Let's substitute it here. So it will 1 minus cos square upon cos square. So this could be written as a square minus b square. That is a minus b, a plus b. So it is a minus cos, 1 minus cos, 1 plus cos upon 1 minus cos. This two cancels and you are left with only 1 plus cos. Left side also you got 1 plus cos, right also you are getting 1 plus cos. Therefore, LHS is equal to RHS. Hence, proved. Yeah. Fifth question. Cos minus sine plus 1, cos plus sine minus 1. This is also an important question. This has been asked many times in the board examination. Please keep a note of this also. See that you understand this and learn it. Practice this question many times so that you understand it. Now what I am doing it, I am putting a bracket here. And I put a bracket here and there's a minus sign. So this should, because of this minus should be plus. So that's why when I put a bracket here, the sign has changed and it has become sine minus 1. And this is because there's a plus sign, doesn't matter. So it is just put as plus sine a minus 1. A plus b, a minus. Okay, now I'm going to rationalize the denominator. Rationalize the denominator means what will be? I'll be multiplying the denominator with the opposite sign. So it is cos a plus sine a minus 1 and I'll take it as cos a minus sine a minus 1. Same thing in the numerator. Now if I open the brackets, now you see how it is. cos A minus sin A plus 1, cos A minus sin A plus 1 upon here cos A plus B, A minus B. So this is how it takes. So it becomes cos A minus sin A plus 1 whole square upon cos square A minus cos A minus 1 whole square. Here I am going to use the two identities A plus B, A minus B plus C whole square. That is A square plus B square plus C square minus 2AB minus 2BC2 plus 2CA. And with denominator for this term, we are going A minus B whole square is A square plus B square minus 2AB. So this identity we have learned in 9th standard, and this we have been learning from lower 7th standard itself. So let us see how to use this. And use that here in your equation, A is cos, B is sine, and C is 1. So cos square plus sine square plus 1 square minus 2 into sine cos, 2 into sine into 1 plus 2 into 1 into cos upon cos square minus sine square. Here A is sine, B is 1. So sine square plus 1 minus 2 sine A into 1. So this will become sine square cos square 1 square minus 2 sine cos minus 2 sine minus 2 cos upon this. Sine square plus cos square is 1. 1 plus 1 minus 2 cos sine minus 2 sine minus 2 cos upon. Now here cos square minus sine square. And this is 1 square. So I bring minus 1 this side first. So when I bring minus here, it becomes minus 1 minus bracket 1 minus cos square minus sine square and plus 2 sine. So this becomes 1 plus 1, 2 minus 2 cos sine minus 2 sine plus 2 cos upon 1 minus cos square is sine square. So minus sine square plus 2 sine. Minus sine square is minus 2 sine square. The denominators minus 2 cos plus 2 cos minus 2 sine cos. I have rearranged the terms here. Slight rearrangement of terms is done so that you can take out common from the two. Okay. The idea behind rearranging is to take out common. So I have written this term first minus 2 sine cos and then taken 2 minus 2 sine upon minus plus 2 sine first writing and minus sine square minus 2 sine square. So 2, 2, 2, 2 everywhere there, take out 2 common from the first. So if you from these two terms, if you take out 2 cos, you have 1 minus sine. From these two terms, take out 2 common, 1 minus sine upon 2, if you 2 sine, if you take out common, it becomes 2 sine into 1 minus sine. So 1 minus sine, you take out common. Again 2 is common, so it becomes 2 cos and 2. 1 minus sine A is taken out of common. If you take out this common, you are left with only 2 cos A and here only plus 2 upon 2 sine A into 1 minus. Now you see these two gets cancelled. Okay, I've written this. This 2 cancels. These 2 also cancels. You are left with cos, cos A plus 1 upon sine. So I can write this as 1 upon sine plus cos upon sine. 1 upon sine is cosec and cos upon sine is cos. This is what you have to do. Okay. So it's a big proof. We try to understand it. If you are not able to understand, please go through this sum again once more. Just see this recording of this particular sum again. You'll be clearly able to understand it. Now let's go to the sixth question now. Sixth one. Here we first need to rationalize it inside the root sign. Rationalize inside the root sign. So rationalize the denominator inside the root sign. It will be 1 plus sine upon 1 minus sine. We will multiply with 1 plus sine, 1 plus sine. The numerator it becomes 1 plus sine whole square upon sine square minus 1 sine square. So this is 1 minus sine square is cos square. So the denominator is cos square. It becomes 1 minus sine whole square upon cos square. This square and root cancel. This square and root cancels. So it will be left with only 1 minus sine upon 1 plus sine upon cos. Let us break down this. It becomes 1 upon cos plus sine upon cos. 1 upon cos is sec and 1 upon sine upon cos is tan. This is what you have to prove. So for the simple proof, now let us take the second one. Seventh one. Now you will see here sine theta, sine raised to 3 theta, cos theta, cos raised to 3 theta. So let us take out first common. Take out common, it becomes 1 minus 2 sine square theta. Take out cos common, 2 cos square theta minus 1. Now minus 2 sine square, that means sine square, 2 times it is there. So, and cos square, 2 cos square means cos square, it is also 2 times. So you can write this as 1 minus sine square theta minus sine square theta, 2 times. Here cos square minus sine, so I take on a bracket outside 1 minus, therefore it will be 1 minus sine square is cos square minus sine square. Here also cos square minus sine square. 1 minus cos square is sine square. This full bracket cancels. It is sine upon cos, which is nothing but tan. This is here for the next. Here you may slightly find it difficult. Here it is. What I have done is cos square theta. So 1 minus 1 plus cos square. So minus 1 plus cos square it is. So when I take out minus, it has become minus 1 bracket 1 minus cos square. And 1 minus cos square is sine square. So cos square minus sine square. Here again, a plus b whole square by using the same identity. This is also most frequently asked question. Please make a note of this also. It's an important question. A plus b whole square, a square plus b square plus 2ab. This identity you are using for both these brackets. So let us use it. Sine square plus cosec square plus 2 sine cosec plus cos square plus cosec square plus 2 cos sec. Okay. Now, cos square a is 1 plus cot square a. So I'm going to represent this with 1 plus cot square a. And sec square a is equal to 1 plus tan square a. Sec square a I'm going to represent with 1 plus tan square. So it becomes sine square 1 plus cot square plus 2 sine. Cosec is 1 by sine. Cos square plus sec square I'll write as 1 plus tan square plus 2 cos into sec is 1 by cos. So this sine cancels. Cos cancels. So what is left? Sine square plus 1 plus cot square plus 2 plus cos square plus 1 plus tan square plus 2. So 2, 3, 4, 5, 6. Okay, and this sine square plus cos square, bring it together first. Sine square plus cos square, bring these two terms together. 1 plus cot plus 2 plus 1 plus tan square plus 2. Sine square plus cos square is 1. Sine square plus cos square is 1. So let us write this as 1 plus cot square plus 2 plus 1 plus tan square plus 2. So 2, 3, 4, 5, 6, 7. The total is 7 plus cot square plus tan square. 7 plus cotan square plus cot square. This is what we want to do. Okay. Next. Here again, let's multiply these two brackets. Let's take this to left side. Cosec is 1 by sine into sine. Sec is 1 by cos into cos. So multiply. First take the LCM here. You got 1 minus sine square upon sine and 1 minus cos square upon cos. 1 minus sine square is cos square. So it becomes cos square upon sine and 1 minus cos square is sine square. So sine square upon cos. So this becomes 1 cos and 1 cos cancels. One sine and one sine cancel. It is only cos sine. This was the left side. Now take the right side. See what happens right side. Here again write it in terms of sine and cos. 1 upon sine cos plus cos sine. Take LCM here. 1 upon sine into sine square plus cos into cos is cos square upon sine cos. Sine square in plus cos square is 1. So it becomes 1 upon 1 upon sine cos. This goes to the numerator. It becomes sine cos. So the left side and right side both are equal. Therefore, it is true that the left side and right side both are equal. 10th question. Here in this question, we have to prove this is equal to tan theta and this also is equal to tan theta. So it's two parts of it. So let's do the first part. 1 plus tan square upon 1 plus cos square. 1 plus tan square is sec square and 1 plus cos square is cosec square. Sec is what? 1 by cos. So sec square in divided by cosec square. Sec is what? 1 by cos square and cosec square is 1 by sine square. Division, so take a reciprocal here, it becomes 1 by cos square into sine square by 1. Sine square upon cos square is nothing but tan square. So this is the first. Now let us take this part. 1 plus tan upon 1 minus cot bracket raised to 2. Again take LCM. Sine upon cos. Cos upon sine. Taking the LCM, it becomes cos minus sine upon cos. And this is sine minus cos upon sine. Okay. It will be cos minus sine upon cos divided by sine minus cos upon sine. Division it is, so you have to take the reciprocal of this. It becomes sine upon cos minus sine minus cos. Now this is cos minus sine, this is sine minus cos. So if you change the sign, you can write it as, take the minus sign outside. So it becomes minus cos and minus minus plus sign. So now you can cancel these two. These two will cancel. It will be sine upon minus cos whole square. When you take a square of it, it is minus becomes positive. So it is just equal to tan square. Hope you have understood it. Clear? Okay. So this was the last question of the exercise. If you have understood, if any doubt, just go through the thing once more. Go through the video once more. You will be able to understand it. Clear? In case you have any doubt, you can call me. I have written my number on the thumbnail, and so please subscribe and click on the like button. I think it's clear. Okay, so this was exercise 8.4 of Introduction to Trigonometry chapter.